Okay guys, so right here we have a Komatsu D51PX bulldozer. Now I was doing some hoses on it already. It had blown a drive motor hose. So coming from in the back there to the drive motor that's driving this. So I had all the covers off, I changed all the hoses, I got the unit mobile. And the customer told me that the blade was kind of lifting slowly. So I hop in, I get it moving, make sure I got oil, and I did have the blade lifting for a little bit there. We'll just start it up here. And the blade's lifting now. So, what I think we should do is just throw a couple gauges on it, just try to see what's going on. I believe this is the valve here. So these little hoses here are coming from our joystick. So it's a pilot joystick. And they're coming down here, they're pushing these spools over, which moves the blade. So these are our blade functions in the back there. So I may just look a few things up in the computer here. I'm gonna guess that either this is the feed, or it could be the return, because it's coming off. It looks like it's teething with the filter. This could be the feed back here. And we'll just throw a couple gauges on to see what's going on. And we'll figure out which one of these is to blade raise, just so when we're operating a function, we know what we're connected to. And we might throw a gauge on this, and either a gauge on this guy here or a gauge on this one here. Okay guys, so this is our information from Komatsu. Basically those two side ports for pressure and tank, we're not gonna be able to get a gauge right on that line. Just because of the style of fittings they are. So by looking, this is the valve there that we were looking at there. Basically we're gonna tie into lift down, which is the yellow. So if we come over here, yellow is right here. So what happens is when you make the blade go down with the joystick, it should be sending pilot oil right here and pushing the valve and moving to create pressure. So we're going to throw a gauge on there to see if we have any pressure here. We probably don't, was what I would imagine. And when it's not working, and we're gonna have to try and find there's got to be like a safety coil because of this red lock bar. I'm going to imagine that somewhere in the machine there's a coil that's going to turn that on and off, and if it's failing, it could be causing problems. The only other gauge I have on me right now goes up to like 5,000, so this will be better to see what's going on. Okay, if you see there, guys, right about 200 psi, just over. That seems really low. Like the machine should be able to pick itself up. What I'm gonna do is try revving the machine up a little bit. Starting to lift the machine. Still about the same pressure, which is weird. It seems like that's all it takes. Maybe that's all you know, blade up gets. And now it seems to be lifting the blade fine. So. Again, even to lift the machine, you know, we're lifting right now. We're still only getting up to about 200 psi there, which I believe is going to be low, but okay, guys, back to the computer here. So what we were doing there was lower, and this is our work equipment pilot control pressure, and it's showing 1.37 MPa, which I believe, you know, we had about 205 psi, which is about 1.4 MPa, so we're above the minimum, and that checks out. So it looks like we're getting oil to our joystick when needed. And the blade really still wasn't moving, and the pressure was right. So the next thing we're going to check here is our pressure for the blade itself. So this is what we were checking there, was the pilot pressure, which you can think of as the control oil. That's like a lower pressure oil that's going to be controlling the higher pressure circuit. So now we're going to hop into testing out the actual work equipment circuit and see what's going on there. Okay, guys, it looks like they have a port here already, which I do have the quick connect to plug into this, so we'll plug that on there. And then this is on a it's a maximum 5800 psi gauge, so we'll see. We left the pilot gauge is still on. Okay, we can kind of watch them side by side, but this isn't actually going to a function. This is just showing that we have pressure at the valve, I believe. We're going to continue with blade down. It is raising the machine. We are getting some pressure there. Okay. Oh, there's a machine there. The pressure kind of seemed to be popping around there. Okay guys, so the blade's lifting right now. Again, I kind of wanted to see what the pressure was there when the blade wasn't lifting, so we might leave it a couple minutes here, kind of hop in and out, try it out. Just seeing it kind of bounce around like that, and again, it looks like our pilot system is working. And again, we're gonna wait before we make any kind of calls or which direction we're gonna go until we see it with the blade not lifting again, and what kind of pressure is there. Again, I believe this pump should be able to kind of stroke itself up and down depending, you know, if oil is needed. There's like resistance, and the pump should stroke itself up to build more pressure, to give more flow, I guess. And then again, if the pump's not needed, instead of draining power all the time, it kind of strokes back down. And just seeing the kind of how it was kind of jumping there, I wonder if the something's going on in the pump there for the control side of it, and maybe it's starting to stick, or something's maybe needs to be cleaned up in there. Whether it'd be better to just replace the pump, that's another thing too. But again, we're not gonna make any kind of calls like that yet. We're gonna do more testing and go from there. Okay, I'm gonna start the machine up here. Hydraulic fan for this machine is sharing the pressure from that work equipment. The fan is spinning. I'm not sure if the code's still active, but I was getting a code that the sensor for the fan was short circuit. They don't seem to be having that code anymore. Okay. You see the pressure's kind of jumping up and down there. Doesn't seem right. Okay guys, so I'm gonna take the lock bar up, try to raise the blade. It's not raising. I'm holding it in raised right now, and we can see there's no pressure coming from the pump, which makes me believe the pump should be being told to stroke up right now, and it's not stroking up. Again, from looking at the hydraulic oil that was in here, okay, I'm pressing down with the blade now. I'm gonna go back up. So it's starting to come up in pressure. Again, the hydraulic oil is quite dirty in this machine. I'm going to say that I think it's called a compensator on the pump is getting stuck up and not wanting to stroke the pump up as it should. Okay guys, if you can see here, that's measuring the fan RPM, which is being driven by this work equipment pump. So we're going to crank the RPMs up here and see if the jumping of those RPMs kind of matches the jumping on this gauge. It looks like it's staying a lot more steady now. So our pressure's holding steady and our fan speed's holding steady. Okay guys, so back at the computer here, this is the pump we're looking at there, that circle. And these are kind of the valves, your load sensing valve, and I believe this is your pressure control valve. And if you see this little spring here with the rod, basically as this is pushed either way, it's either going to stroke the pump up and make more pressure, or come back and lose and bring pressure down. So we could either have a problem. Sometimes these servos, or inside the actual pump, the actual swash plate itself, which is moving, can get seized up, kind of get stuck in some spots. We could also have a problem with one of these valves. If one of them is leaking by or something, it could be making it difficult to stroke the pump up. Okay guys, so hear me out. It doesn't really give me information, but I think what's happening is if you see this piece here that is showing I can rotate back and forth, that's the swash plate. So when it's flat up and down, that's the minimum oil it can put out, and the more it's tilted, it moves some plungers, and that will actually increase the oil coming from the pump. Now, there looks to be two adjustments, like a max and a minimum swash plane angle. Okay guys, so I probably moved it about half a turn. I know I said I was going to do about a quarter, but I can get back under there and move it again. I just want to see if I can visually see the difference on these gauges, and then we can try to fine tune it, and we can go from there. Okay guys, this is at idle here. Still seems to be gotta be jumping around a little bit. And right now the blade is not wanting to lift. So we're building pilot pressure there. Just starting to build some pump pressure, so. Our control side looks to be fine. So whether it's a problem with the actual, I guess with a load sensor or the pressure control, whichever that way. Again, I got a feeling, just by kind of seeing the hydraulic oil, seeing a few things, it's probably going to need a hydraulic pump. Like, again, we could take that valve off the pump and try to take it apart, but I don't think that's going to do much good, nor do I even know if you can get parts for the internals of that. So I'm going to try one more time doing a slight adjustment to that pump, and if we can get it to just ramp up a little bit so it's always kind of have some more pressure there, I think it may kind of help this issue. But again, probably not the right way to go about it, but we're just going to do what we can. So okay guys, so I talked with the customer. I let him know that you know, I could come back on a different day. Again, it's kind of the end of the day. I gotta make it down to another place to pick up parts for my job tomorrow. And I kind of let him know, hey, I can come back. I can do a few more tests to kind of just 100% say, hey, you know, we have a problem with this hydraulic pump. Okay guys, so an update on this Komatsu. Basically, I went back out there. He was having some troubles with the machine moving after I did the hoses. And again, he wasn't there when I finished it up, so I didn't want to tear up his lawn because it's on, you know, it's on a personal property, let's say. And so basically, I did make sure the machine moved. And again, the hydraulic tank was not full yet. We had put 3 pails in it, and we still needed another 3 pails really to get it full. So I guess they had been testing it out and using it for a while, and then it stopped driving altogether. So when I came back out to it this time, the hydraulic tank was full, and the oil in the sight glass was black. So like, it's just very, very dirty. And again, I had to take apart part of his pump for the hydrostatic system for the drive to clean out some little filters in there that were getting plugged up with dirt, not allowing the machine to drive. So I got a feeling for this blade issue, realistically, there's probably a bunch of junk in that pump just getting caught up and stopping it from wanting to stroke up and or be held where it's supposed to be held. Again, there is more tests we could have done, and in the future we may, if we end up taking the job on. Basically, I've let him know that he should have a full hydraulic system flush at this point in time. Like, you know, a few flushes, you know, cleaning the lines out. You know, it's a fair sized job. But it's just it's so dirty now that realistically it needs to be cleaned. And so we'll really see, before even really doing any more testing, I would like to pull the control side of the pump for that implement pump off and just inspect it, clean it up. And I feel like we stuck it back on and maybe made some adjustments if needed. Again, not to where I had tried adjusting, but to the actual, either the LS or the PC, I believe they call it in the manual. One of those valves would probably bring us to where we need to be. Again, I don't think anything's damaged. I think it's just so much dirt in there that things are just getting caught up. But we'll see if we take on the job in the future. And if you like the video, thanks for watching. Please like and subscribe, and stay tuned for more. See ya.